Okay, so now that we're done the procedure, okay, you have all of the observations there already. Okay, this morning, in case you want to double check anything, I did put the video up of me doing the lab. Okay, so if you wanted to double check any of your observations, or you're not here, okay, or whatever, okay, you can use that video obviously to do that. It's only 9 minutes long. Okay, it's super quick if you wanted to double check. Okay, but obviously what we're working on here, what we want to talk about is the analysis and interpretation. So the analysis questions for this lab. Now, I don't want you guys to lose marks where people usually lose marks on this lab. Here's where they lose marks. Question number 1 wants you to write the reactions in both forms. That is, as a word equation, so writing out all the names, and in formula form, properly balanced. Okay, that's analysis question number 1. All you're doing in analysis question number 1 is writing out the reaction in word form and in formula form. Okay? Now we're going to talk about what that looks like, because there's a couple of those reactions that didn't go the way we predicted. Okay, so we're going to look at those. Now, the second question is asking about 2 of the reactions. In 2 of these reactions, precipitates were formed. Okay? Those precipitates need to be identified. Right? So when you're writing out the reaction, you need to look at the products of those reactions and see, using your solubility chart, which of those products are not soluble, and simply identify. Okay, so you're looking at the products of those reactions. Okay, you look at the first compound, check it on the solubility chart. If it's soluble, that wasn't the precipitate. Look at the second one, that one's not soluble, that compound is the precipitate. We have 2 precipitates in this lab, I just need them identified. Okay, that's all you're doing in question number 2. Okay, so all of your analysis is writing out reactions and then identifying the 2 precipitates. That's it. Okay, reactions are written out in word form and in formula form. If you don't write it in both forms, you're going to lose big marks. Okay, don't want you to do that because I know you guys all know how to do that already. Okay, all right. So if we are looking at our reactions, okay, we had predicted these on Friday. Okay, but 2 of them didn't go the way we predicted. Okay, pair 1 and pair 2 did not go the way we predicted. Now, also, in question number 1 in the analysis, you do not need to write out the reaction. That's why it doesn't have it there. Right? It goes pair 1, pair 2, pair 3, and then it goes pair 6, 7. Okay? You do not need to write the reactions for pair 4 or 5. All right, so in pair 1, on Friday, we predicted that this would be a double replacement reaction and that the products were going to be sodium chloride and ammonium hydroxide. Okay, what happened in that reaction? What were your observations for that reaction? Nope, that shouldn't have fit. This is the first reaction, pair A, or pair 1. Nothing visible. It smelled really bad. Okay, if it smells really bad, what was produced? Gas. Okay, are either of these compounds a gas? They're both ionic compounds. They can't exist as a gas unless there's thousands of degrees Celsius. Okay, so neither of those is a gas. So here's what I'm going to do to help you out with predicting the products of this reaction. Okay, the gas that was produced in that reaction is ammonia. If I told you that it smelled a little like Windex or glass cleaner, you'd probably go, oh yeah, that's exactly what glass cleaner smells like. Okay, this is the stuff that's in glass cleaner or Windex, okay, is ammonia, right? And that's the gas that was produced in that reaction. So, here's the other help I'm going to give you for this reaction. Okay, this is now still going to be a double replacement reaction, but it's going to be with what's left. So there's still going to be 2 ionic compounds that are going to be formed here. Okay? I've got 1 N and 3 H's on the product side. Those came from here. Okay? So they came from here, which means that now that N is gone and 3 of the 4 H's is gone, which leaves me with 1 H and 1 chlorine. Okay, so there's your new double replacement reaction. What are you going to get when you mix this and this together? What are the other two products of that double replacement reaction? Okay, that's what you have to figure out. Or what are the other two ionic compounds that are going to be produced from having sodium hydroxide react with hydrogen chloride? Okay. All right, pair number 2 also did not go as predicted. Okay, we predicted that we would get this sodium acetate and hydrogen carbonate. Okay, what happened when you mixed the vinegar and the baking soda? It bubbled and fizzed and carried on like crazy. Okay, which means what was produced? A gas. Okay, so we had a gas that was produced in that reaction. The gas that's produced in that reaction is carbon dioxide. That's not what we predicted, and that's fine. Okay, so we have to do the same thing with this reaction that we did with the last one, and that is that we have to figure out what's left after this carbon dioxide is produced. So here's where the carbon dioxide came from. Okay, it came from there, from the hydrogen carbonate. Okay, so we've got 1 C and 3 O's, which basically means now that C and 2 of those O's are gone, which changes this now to that. That's what's left after I remove 1 carbon and 2 oxygens. So can I now predict a double replacement reaction, okay, between this compound where hydrogen's acting as the metal, acetate is the non-metal, okay, and sodium hydroxide? What are the other 2 ionic compounds that I'm going to get over on that side as a result of that? Okay, that's what you have to figure out. All right, the other ones, they went pretty much as we predicted. So all you have to do is write them out in words and balance them. Okay, down in your analysis section. Okay, questions on that? Okay, so that should help you out with question number 1. Okay, quite a bit actually. Okay, and then you've got obviously question 2 about the precipitates. Now, for the conclusion, and remember that you're just going to copy and paste your hypothesis. Okay, you copy and paste your hypothesis, and then you need to talk about whether you can accept it or reject it based on what you saw in the lab. Okay, in our hypothesis, we talked about the signs of a chemical change, what happens in a chemical reaction. So you need to talk about, did you see those signs of a chemical change? And why do they mean that atoms did what you said they were going to do? Okay, remember we said you were talking about Dalton and his atomic theory. Okay, what did he say happens in a reaction? So why does the evidence you saw support what he said? Okay, that's what you have to talk about in the part of your conclusion where you're accepting or rejecting. Okay, then you got your evaluation, your 2 sources of error. Okay, 2 sources of error and ways to fix them. Right? Yeah, the lab went pretty well. Okay, but there were probably still a couple of things that could have gone a little bit better or that could have caused error that we didn't notice. Okay, those are the things we want to watch for. Okay, one of them could have been a similar problem to what we had in the first lab, okay, about having all the samples at the front of the room. Okay. All right, you have the rest of the class to work on your lab report. So you should be able to get a pretty decent chunk of it done and not have very much homework. It is due this Friday at the start of class. Okay, so make sure you have it ready for this Friday, March the 6th. Okay. Any questions? Okay, get to work then.